We will be exploring the physics of jumping off of a cliff into water. Specifically, we will look at what it takes to perform a gainer. A gainer is a backflip in which the person attempting it is actually moving forward.
What we'll look at today is how we should approach doing a gainer off of Pillar Rock, pictured at Lake Del Valle in Northern California. We will ask several questions that build on each other, so make sure to write down your answers throughout the presentation.
To find out how high the jump is, we can time how long the jump takes, which is about 1.2 seconds. Though it is possible to use the gravitational constant to find the height, it is probably easier to just give an estimation for this problem.
Pillar Rock has an interesting feature for jumpers in that the rock actually extends about 6 feet forward past the jumping point. This means that jumpers need to push themselves forward enough to avoid hitting the rock on the way down.
We can solve this by looking at the horizontal distance that the jumper must cover in the time that it takes them to fall. I like to add an extra couple feet onto the jump just in case. Numerous forces act on the jumper as they are on the rock itself, but what acts on the jumper during the flip?
While the jumper must apply some force to jump from the rock, the only force affecting the jumper throughout the flip itself is gravity.
A huge part of any jump, especially the gainer, relies on friction. The jumper must always make sure that both their foot and the rock are dry. This ensures the maximum amount of friction. If their foot or the rock was wet, lessening the effect of the friction, the jumper could slip.
The work done by gravity during the jump can be calculated by finding force times the distance. This means that if the jumper were to fall 6 feet from the rock or 12 feet from the rock, the same amount of work would be done by gravity.
Here, we'll look at a flip off a 1-meter platform and one off a much higher cliff. Both turn 2 radians, but at different rates. Notice that when the first jump has completed the full rotation, the second one is only about halfway through. Given the amount of rotation and the time of the jump, we should be able to find out the angular velocity during the flip. Hopefully now you are more informed about what it takes to perform a gainer. Thanks for watching and good luck jumping.